Warning! In this video I'll be working with chemicals which can cause extreme exothermal reactions. Using them without appropriate safety equipment and supervision can be very dangerous and is done at your own risk. This video is for educational purposes only.
A good way to see a rocket engine and to understand how it basically works would be to see it like a controlled explosion or a very violent and prolonged fire. So by association, it should contain the same three key elements that you find in such fires, right? You have fuel, initial heat, and oxygen. If you take one of those out, the fire just stops or doesn't cooperate. And it's exactly the same with the rocket engine. For it to work, you need fuel, which comes in various forms from kerosene to acrylic, and you need heat, which comes in great quantities. Naturally, that's not a problem. And you need oxygen, which is exactly the difference between the fire you would find at home in your chimney, for example, and the combustion that happens inside of a rocket. Because to achieve such power, lift, and immense thrust, the oxygen in the air is simply not enough. You have to add some more. And that's even worse in a closed environment, such as in a rocket or in space. So, what do you do exactly at home to make a fire more vivid, more powerful? You add some oxygen, you blow on it. So, that is exactly the role of an oxidizer. It adds oxygen to the combustion to make it more intense, more powerful. So, to make rocket fuel, you have to take that into account. To achieve such combustion, the first thing you have to do is add an oxidizer. So today, to make our own rocket fuel from household items, the first thing we're going to do is synthesize our own oxidizer.
So, for the oxidizer I chose potassium nitrate for obviously its oxygen contents, but also for its molecular stability, which makes handling it safer. It's also super soluble in water, so crystallizing it to purify it is way easier. And finally, it's obviously one of the safest oxidizers to work with out there if you compare it to other MSDS hazard statements. Its solid form at room temperature makes it then the perfect candidate for solid state rocket fuel. To synthesize this potassium nitrate, you're first gonna need some salt substitute, which can often simply be found in grocery stores around the world. The key ingredient here is potassium chloride, or for short, KCl. You want it to be the main ingredient. You will also be needing some of these instant cold packs, which contain this white granulated substance, and a water pack, which is normally popped to create an endothermic reaction with the main ingredient, which here is calcium ammonium nitrate. Depending on the regulation where you live, the content of nitrates can vary, but is often under 28%. Our goal here is to isolate these nitrates, which are often used in agriculture. For the experience, I recommend using some distilled water because we're going to have to do a lot of crystallizations and reductions, so you don't want any chemical residue. It's a way to achieve greater purity of the final potassium nitrate crystals. So, chemical-wise, we should now have some potassium chloride and some hydrated calcium ammonium nitrate. If you first represent these ingredients in their ionic form and get rid of spectator ions, this is how we should theoretically get our potassium nitrate. Now that we have this information, it's time to start measuring what you'll need. If you want to simply test the fuel and make around 200 grams of it, I recommend starting with about 3 packs worth of calcium ammonium nitrate, which should amount to 360 grams with this particular brand. If you want to make more or less, simply keep the following proportions. Then, for the potassium chloride, or here the salt substitute, you'll need around 390 grams of it to respect the 1-to-1 molar ratio with the ammonium nitrate. Once again, if you want more or less in the end, you'll need to respect proportions and use the respective molar masses in consequence. Now let's get to business. First, we're going to need to dilute the calcium ammonium nitrate in 500 milliliters of distilled water. Turn the heat up to make it more soluble and faster. Also, since we're working with dangerously flammable substances, prepare in consequence and please use all the necessary safety equipment. In addition to the fire extinguisher, I strongly recommend a face mask to avoid breathing in powdered chemicals, some good aeration, latex gloves throughout the manipulation, and protective eyewear for obvious reasons. So yeah. Really start to pour it in when the water is warm and start mixing thoroughly with anything but metal. You want to avoid sparks which could start a fire. I strongly recommend using an electric surface to heat your solutions throughout the manipulations as seen here, because you need heat but fire means explosions. So I'm simply using an electric fondue pot which allows me to regulate the temperature as well. So, you want to mix until the gravel-like sensation at the bottom of the pan has disappeared. The lack of residue at the bottom means the calcium ammonium nitrate is completely dissolved. You'll then want to pour this initial solution through a simple funnel and into a beaker to get rid of the first chunky calcium flakes. The goal here is to purify the solution to simply keep the ammonium nitrate and get rid of the calcium. But here I am. Now that the solution has rested for a few seconds, prepare the first filtration through a coffee filter. This should get rid of the biggest calcium particles. As seen here, the calcium is forming residue, and that's how you know that you're slowly getting rid of it. The filtration here might take a while, so just continue pouring slowly without going above the filter. For the first filtration, you might want to go faster by squeezing out the liquid, which is acceptable at first. It's really to get rid of the biggest chunks, so another way is also to change filters when they get clogged. Here is also the importance of wearing latex gloves. The ammoniac will give a burning sensation in contact with skin or a small blister. Watch for holes.
Memories die out too hard. We were traveling mountains just to find the loudest tea.
Once again, here you can see the initial deposits of calcium. There should be less and less with every filtration. It really feels like sand to the touch. It's like a sandy, watery feeling.
Something to hold on to, gotta find it first. But here I am.
For the second filtration, you want to reheat the filtrated solution in a new pan. As you can see here, we're already making progress with less and less calcium residue at the bottom of the beaker. There is still a little white veil, but eventually it should leave. Throughout the experience, you can always simply rinse your equipment with distilled water and dry it with paper towels, and it should do the trick, but always rinse between operations. For the second filtration, you will do exactly like with the first, but in the goal of achieving greater final purity, you have to let it completely filter out without manually accelerating the process this time. So really take your time. At this point, the solution should basically be translucent, meaning it lost all of its calcium particles. You can as well always swap filters to make the process faster and to assure no calcium gets through. Be careful to avoid having an unfiltered spill. As you can see here, the white residue is still the calcium we're trying to get rid of and is clogging the filter, making the process slower. You really want to get rid of that. For the third and last filtration, you'll follow the same steps as the second and the first, but here double your filtering capacity by adding a second filter in the funnel. This will make the process way slower, but will assure a greater final purity. It will be very slow, but it's a good thing. The slower it is, the more pure is your final product. So take your time and let it drip through while you do something else. Come check on it from time to time, obviously. Here you can now notice that there is no more residue, signifying that we can pass to the next step and that all the calcium is filtered out. So now to the potassium nitrate. You have this ammonium nitrate solution that you want to slowly start preheating. Once that is done, gently pour the potassium chloride that we've measured earlier in the mix. On top of that, add some 500 milliliters of distilled water to help with the dilution. This step is, I'd say, the most crucial, since here we will form our crystals of potassium nitrate. So you really want to take your time. It's all about concentrations once again, because what's happening is that there is an exchange between the potassium chloride and ammonium nitrate, which are in ionic form in the water, which should form ammonium chloride and the desired potassium nitrate. Like with the calcium at first, mix thoroughly until the gravel sensation at the bottom has disappeared. Also, don't worry if it takes time and starts evaporating, it's all included in the distilled water we added in the beginning. It's a lot of mixing. Now that the solution is ready, simply pour it into your beakers. Once the solution is poured in your beakers or jars, I recommend putting them in the fridge for up to 14 hours to help and accelerate the crystallization process. If you want to be sure to get all the potassium nitrate you can keep them in there for longer, but it's a logarithmic curve, so you should not get so much after then. After 12 hours, this is how mine looked. You can really see the crystals forming at the bottom. You can really see the crystals. It's beautiful in my honest opinion. To get them out, you want to start by simply emptying the jars of the liquid into a container that I recommend bringing after to your closest echo center. Then gently pull the crystals out on a sheet of kitchen paper to absorb the extra liquid. I recommend to spread them out to help them dry. As you can see here, they really have a defined crystalline structure. The longer the crystals, the more pure. Now I let them dry there for around 4 to 6 hours. With the amounts I used, I got around 165 grams of potassium nitrate. Now, time to work on the actual rocket fuel. But first, since I'm looking to get the most performance out of mine, I'll quickly recrystallize the potassium nitrate to assure that I get the best quality and purity I can. If I was making fireworks or something else, I would skip this step, but in my case, I find it necessary. So it's simply about making a super saturated solution with boiling water and diluted potassium nitrate, and then slowly cooling it down in a preheated bowl. You should get these really big crystals, but here I've pre-grinded them to prepare for the next step. Fun fact, potassium nitrate is completely safe and even comestible when pure enough. Obviously it tastes horrible, so I don't recommend it. So now the idea is to grind the crystals with a simple coffee grinder to increase the contact surface of the oxidizer in the objective of having a faster reaction and in the end a more intense but shorter burn. The smaller the particles, the more molecules are in contact with the necessary elements for combustion. It also helps with the homogeneity of the fuel in the end.
Memories die out too hard. That we were traveling mountains just to find the loudest tears.
Obviously, with the multiple crystallizations and the higher purity, you lose a bit of potassium nitrate impurities on the way. So as you can see, I'm down a few grams, but it's all in the sake of performance. Okay, So now you have our oxidizer and we need some fuel. You need something dense in energy. In a rocket, every gram is counted, so a good energy density is essential. So here you're looking for something above 14 kilojoules per 100 grams. Also in amateur rocketry, safety is really important since we don't have the equipment or funding government or private entities have. So for our own sake, you're looking for something moderately safe to work with, affordable to buy in bulk, and of good initial quality so you don't have to purify everything yourself. Our best candidate here is C12H22011, which is packed with energy. And it's basically sugar, which is safe, cheap, and pretty pure. It completely satisfies our needs. Combining it with potassium nitrate creates such an immense quantity of gases that it's no question that the resulting pressure will create the thrust you need. So, using basic granulated sugar, you want to respect the 3:1 mass ratio, and with what we have of oxidizer, it should be around 43 grams. Now we're at the final step, where you want to bind the ingredients of the actual rocket fuel. It's the most dangerous part, so I strongly recommend an extinguisher nearby and all the appropriate safety equipment. As you can see here, I'll be also wearing rubber guarding gloves instead of my latex ones, since a simple spark can ignite the fuel and burn my hands, for which latex won't help. Losing a bit of dexterity is worth it in this context. Also avoid metal at all costs to prevent sparks. So you're going to start by mixing the two powders while the pan heats up, so you get this uniform mix before binding. Then when it's ready, you'll want to simply spray it out on the surface and start stirring around.
But we didn't know that yet. So if you want something to hold on to, gotta find it first. But here I am, 'cause I've been laying under palm trees.
I recommend spreading the mix on the pan evenly to make the sugar melt faster, which you can actually see here already happening. Having it melt is essential to bind the two together and to form the paste of the solid state rocket fuel. The sugar caramelizing, it should slowly turn brown, and when it's about this color, you can start disposing of it in your motors. Here I'm using plastic cups because I'm simply prototyping for the moment, and we'll build a more solid casing in the next project. So you can simply pour it in. It feels almost like honey at this point. A good way to plate the propellant is to scrape it off your spatula directly into the cup to avoid making a mess, like shown in the video. When placing the fuel into the motor, try to form a little hole in the center to get a more uniform exhaust by creating a vortex of hot gases. It also helps when lighting up the rocket. When all is done, clean the propulsion chambers and around the exhaust to keep it the most symmetrical possible and to avoid bits of misplaced fuel to influence the combustion. You want unidirectional thrust after all. With this final step completed, you now have some homemade rocket fuel ready for some testing. Now, to the fun part.